Have you ever wondered about the true average of something, especially when dealing with data or uncertain outcomes? When we talk about averages, it often seems straightforward, but in statistics and machine learning, there are important distinctions to make. Today, we will explore two fundamental concepts that are often confused. The core difference between mean and expected value is their application. The mean describes the average of an observed set of data points, while the expected value represents the average outcome of a random variable based on its theoretical probability distribution. Let us break this down. The mean, also known as the arithmetic mean, is calculated by summing all the values in a particular dataset and then dividing by the total number of values. It is a descriptive statistic that tells you the central tendency of an actual recorded sample of data. For example, if you measure the heights of 10 students, their mean height is simply the sum of their individual heights divided by 10. It is a concrete number derived from what you have already observed. The expected value, on the other hand, is a theoretical concept. It represents the long-run average outcome of a random process if you were to repeat it infinitely many times. It is not calculated from observed data, but rather from the underlying probability distribution of a random variable. You find it by multiplying each possible outcome by its probability and then summing these products. Imagine a biased can where heads appear 70% of the time. The expected value of a single flip, if heads is 1 and tails is 0, would be 1 times 0.7 plus 0 times 0.3, which equals 0.7. So, how do we use these? You would use the mean to summarize and understand the characteristics of data you have already collected, such as the average accuracy of a machine learning model on a specific test set. You would use the expected value when you are modeling future or uncertain events, making decisions under risk, or trying to understand the inherent central tendency of a random variable itself, like the expected error rate of a new algorithm before you even run it. An interesting connection is that the sample mean you calculate from a dataset is often used as an estimate for the true expected value of the population from which that data was drawn. The law of large numbers tells us that, as the size of your sample increases, your sample mean will converge and get closer and closer to the actual expected value. This makes the sample mean a powerful tool for inferring characteristics about an entire population, even when you only have a limited amount of data. Understanding this distinction is vital for accurate data analysis and model building in machine learning. It helps you correctly interpret your results, make more informed predictions, and better comprehend the theoretical underpinnings of probabilistic models. This knowledge allows you to move beyond simple averages to a deeper understanding of how chance and observation interact.